In this section, you will apply what you learned about factors to consider when selecting tools and the AWS tools and services that are available to a gaming analytics use case. Understand the use case and business needs to determine the potential solutions using AWS tools and services. Also, consider the personas and their functions within that context as you select AWS tools and services. A gaming company collects and analyzes data on an ongoing basis. The DevOps engineer monitors the health and performance of gaming servers, and the data analyst continuously analyzes player statistics and explores usage patterns. Business users also analyze data to showcase and visualize important information to leadership periodically. Let's look at how 3 different roles, analyst, business user, DevOps engineer, might use a gaming analytics pipeline within the company. The servers and back-end infrastructure that support the games produce data that Amazon Kinesis Data Streams ingests through Amazon API Gateway. Amazon Kinesis Data Analytics and Kinesis Data Firehose process the data from Kinesis Data Streams in real time by invoking AWS Lambda functions. These functions process and transform the data. Amazon S3 then ingests the data from Kinesis Data Firehose for further batch analysis. Amazon CloudWatch provides real-time monitoring of the gaming servers, and the logs and metrics are stored in Amazon S3 for further analysis and visualization. Athena queries the log files that are stored in S3 or connects directly to CloudWatch to query the log data with SQL for analysis. QuickSight is used to create in-depth visualizations of server and back-end performance metrics. These capabilities enable predictive analysis of the infrastructure burden and help identify areas of potential concern. Finally, engineers use OpenSearch Service to perform real-time monitoring, as well as debugging and other troubleshooting. The analyst in this scenario is interested in helping developers improve gameplay experience by analyzing player statistics, such as identifying what vehicles or tools the players use. Similar methods can be used to visualize data about the geographic locations of the game's player base. Doing so would help developers determine regions that might need additional infrastructure to support a growing gaming population. This information could also help to identify possible cost savings in regions where the base isn't as large as initially predicted. The business user's focus in this scenario is on summarizing, visualizing, and presenting metrics that are related to management concerns. The business user needs the capability to tailor reports to management's desired scope, which makes QuickSight an excellent tool for data visualization. KPIs for gaming companies include metrics such as conversion rate. The conversion rate measures the number of users who have made a purchase during a specific time period. The ability to turn free users into paying users is a high priority for investors. QuickSight can help to showcase such metrics, including forecasting, effectively. The DevOps engineers perform real-time monitoring of the gaming servers and back-end infrastructure to ensure that gameplay is smooth and uninterrupted. They use OpenSearch Service to visualize the health of gaming servers and back-end performance metrics in real time. These capabilities enable predictive analysis of the infrastructure burden and help identify areas of potential concern. Here are a few key points to summarize this section. The granularity of visualized insights was shown in the gaming analytics use case. Daily batch aggregates of client usage patterns were visualized by using Athena. Consolidated aggregate KPIs were visualized for leadership through QuickSight. Continuous health and performance monitoring was visualized with OpenSearch Service. Keep the influencing factors in mind when you select AWS tools and services. Multiple solutions exist to meet the business needs of data analysis and visualization. This section summarizes what you have learned and brings the module to a close. This module described factors that influence selecting analysis and visualization tools. You compared AWS tools and services for data analysis and visualization. Ultimately, the module has prepared you to determine appropriate AWS tools and services to analyze and visualize data based on influencing factors: business needs, data characteristics, and access to data. Here is a sample exam question for this module. A company's web application produces 250 gigabytes of clickstream data per day, which is stored in Amazon S3. The company wants to use the data to find out how quickly the application's web pages loaded during the last month. They want to be able to compare month-to-month data to gain insights. Which data analysis and visualization solution would provide these capabilities while also minimizing the cost and complexity? What are the key parts of this question? The question notes that 250 gigabytes of clickstream data per day is stored. The goal is to compare month-to-month data to gain insights while minimizing the cost and complexity. You are to select the most cost-effective data analysis and visualization solution that you would consider as a data engineer. Now, let's look at the answer choices. The possible choices include: A, use OpenSearch service to analyze and OpenSearch dashboards to visualize the data. B, use Apache Spark to analyze the data and Amazon EMR Hive to visualize the data. C, use Kinesis Data Analytics to analyze the data and Microsoft Excel to visualize the data. And D, use Athena to analyze the data and QuickSight to visualize the data. Based on the keywords that were identified in the question, what's the correct answer? We'll pause for a few seconds before discussing the correct answer. If you need more time to consider the answer choices, pause the video. The correct answer is D. Choice A, use OpenSearch service and OpenSearch dashboards, is not the most cost-effective solution. It isn't cost-effective to collect and keep large amounts of historical data to use with OpenSearch service and OpenSearch dashboards. Choice B, use Apache Spark and Amazon EMR Hive, is not an appropriate solution for data analysis and visualization. While Spark can be used to process the data, Amazon EMR Hive does not offer capabilities for data visualization. Choice C, use Kinesis Data Analytics and Microsoft Excel, does not meet the requirement to minimize complexity. Needing to download the data increases complexity and prevents the solution from being scalable. Choice D, use Athena and QuickSight, is the most cost-effective and appropriate solution for the analysis and visualization of historical clickstream data over time. That concludes this module. The Content Resources page of your course includes links to additional resources that are related to this module. Thanks for watching.
Welcome to the Automating the Pipeline module. This module focuses on automating infrastructure deployments for data analytics and machine learning or ML workloads. This introduction section describes the content of this module. This module discusses the benefits of automating your pipeline by using infrastructure as code and step functions. You'll learn about flow states and step functions and how to use them to control and direct your workflows. You'll also examine the elements of the Step Functions Workflow Studio. The objectives of this module are presented across multiple sections, each with its own video. The module wraps up with the sample exam question. This section discusses the benefits of automating the infrastructure deployment in support of pipelines. In the past, the systems administrator would be manually notified when the application server crashed. The administrator then needed to manually launch a new server. Instead of following that traditional pattern, a best practice is to configure Amazon CloudWatch to automatically detect a crash. When that crash is detected, the administrator is notified and a new server with the same configuration is launched in parallel. All of these steps happen at the same time without human intervention. AWS offers built-in monitoring and automation tools at virtually every layer of your infrastructure. Take advantage of these resources to ensure that your infrastructure can respond quickly to changes. You can automate detection of unhealthy resources and launching replacement resources. You can even be notified when resources are changed. By removing manual processes, you can improve your system's stability and consistency, as well as the efficiency of the organization. In the Securing and Scaling the Data Pipeline module, you learned about infrastructure as code. You also learned about services such as AWS CloudFormation and AWS Cloud Development Kit, AWS CDK, that can assist you in automating your pipeline. Let's review some benefits of using the infrastructure as code model. Repeatability is a great advantage of infrastructure as code, giving you the ability to deploy an exact replication of the same environment over and over again. For example, you can use a CloudFormation template to roll out a development environment and then test automatic scaling and the applications. Reusability means that after a successful test, you can use that exact template to launch resources that have been thoroughly tested in the development environment into a new production environment. If you build infrastructure with code, you gain the benefits of repeatability and reusability while you build your environments. In the example shown, a single template is used to deploy network load balancers and auto-scaling groups that contain Amazon Elastic Compute Cloud instances. Network load balancers distribute traffic evenly across targets. With one template or a combination of templates, you can build these same complex environments repeatedly. When you do this with AWS, you can even create environments that depend on conditions, meaning that what you build is specific to the context where you created it. For instance, you can design a template to use different Amazon machine images based on whether the template is launched into the development environment or the production environment. The repeatability and reusability benefits of infrastructure as code can help you to deploy consistent infrastructure packages that are tailored to support your data analytics and ML workloads. Here are a few key points to summarize this section. Automating your environment can help you ensure that your system is stable, consistent, and efficient. Such consistency is particularly beneficial in running repetitive workloads that require identical processing methods. Repeatability and reusability are two key benefits of infrastructure as code. By using templates to deploy infrastructure, you can ensure that production environments mirror development environments. This section discusses the continuous integration and continuous delivery, or CI/CD, process. Continuous integration, referred to as CI, is a software development practice in which developers regularly merge their code changes into a central repository. Continuous delivery, or CD, is a software development practice where code changes are automatically built, tested, and prepared for production release. When CD is properly implemented, developers always have a deployment-ready build artifact that is passed through a standardized test process. CI/CD is a DevOps practice that spans the develop, that is, code, build, and test, and deploy stages of the software development lifecycle. With continuous integration, each change is verified with an automated build and test process. In the past, developers worked in isolation for an extended period and only merged their code changes into the mainline or parent branch after their feature was completed. Batching changes made it difficult to merge the business logic and also the test logic. However, continuous integration practices have made teams more productive and helped them to develop new features faster. Continuous integration requires teams to write automated tests that improve the quality of the software that's being released. Teams must also write tests that reduce the time that it takes to validate that the new version of the software is good. Although there are different definitions of continuous integration, it is commonly thought that CI stops at the build stage. Continuous delivery extends continuous integration to include testing out to production-like stages and running verification testing against those deployments. Continuous delivery can extend all the way to the production deployment, though some form of manual intervention occurs between when code is checked in and when the code is released to customers. With continuous deployment, even the deployment to the production environment is automated. Here are a few key points to summarize this section. CI/CD spans the develop and deploy stages of the software development lifecycle. Continuous delivery improves on continuous integration by helping teams gain a greater level of certainty that their software will work in production. This section examines AWS step functions and how to use its elements and interface to build pipelines. AWS step functions can help you coordinate components of distributed applications and microservices by using visual workflows. Step functions provides a reliable way to coordinate components and step through the functions of your application. The service offers a graphical interface where you can visualize the components of your application as a series of steps. Step functions automatically initiates and tracks each step, and it also retries when errors occur, so your application runs in order and as expected. Step functions logs the state of each step, so you can diagnose and debug problems quickly. Step functions is integrated with Amazon Athena, so you can use step functions to start and stop a query run and get query results. Using step functions, you can run one-time or scheduled data queries and retrieve results from your S3 data lakes. With step functions, you define a workflow as a series of steps and transitions between each step. A workflow is also called a state machine, and states are elements in a state machine. A state machine is an object that has a set number of operating conditions that depend on the object's previous condition to determine output. This means that individual states can make decisions based on their input, perform actions, and pass output to other states. Tasks do all the work in your state machine. A task performs work by using an activity or a Lambda function, or by passing parameters to the API actions of other services. Each state machine starts with an input. The state transforms the input and passes the output to the next state. In the Step Functions console, you can visualize your state machine and get near real-time information on your state machine tasks. Located in the Step Functions Workflow Studio interface, the States browser is where you select states to drag and drop into your workflow graph. The Actions panel provides a list of AWS APIs, and the Flow panel provides a list of flow states. You can search all states by using the search field at the top of the States browser. After you choose a state from the Actions or Flow panel to add to your workflow, drag and drop the state to the workflow graph in the Canvas area. A line shows where it will be placed on your workflow. After you add the new state to your workflow, its code is automatically generated. The image in this slide shows the canvas of the Workflow Studio interface. Within the workflow, you can drag and drop states to move them to different places in the workflow. If your workflow is complex, you might not be able to view all of it in the Canvas panel. Use the controls at the top of the canvas to zoom in or out. To view different parts of a workflow graph, you can drag the workflow graph in the canvas. After you have added a state to your workflow, you'll want to configure it. Choose the state that you want to configure, and its configuration options appear in the Inspector panel. To see the workflow code, choose the Definition panel. The code that's associated with the selected state is highlighted. Let's look at the different state types that are available and the functions that they perform within the step function service. Each state has a different function. A task state is a single unit of work performed by a state machine. All work in a state machine is done by tasks using an activity or Lambda function. A pass state passes input to output. As an option, you can add fixed data into the output. A choice state adds branching logic to your workflow. In the Configuration tab of the Inspector panel, you can configure rules to determine which state the workflow will transition to. A parallel state adds parallel branches to your workflow. A wait state will pause the workflow for a certain amount of time or until a specified time or date. A map state will dynamically iterate steps for each element of an input array. Unlike a parallel flow state, a map state will process the same steps from multiple entries of an array in the state input. A succeed state will stop your workflow with a success, and a fail state will stop your workflow with a failure. Let's take a closer look at each of these states and how they are used in step functions pipelines. A pass state passes its input to its output without performing work. Pass states are useful when constructing and debugging state machines. The slide shows an example of a state machine that consists of a single pass state. When the state machine runs, it injects some fixed data, which might be useful for testing purposes. A choice state adds branching logic to a state machine. A choice state must have a choices field whose value is a non-empty array. Each element in the array is an object called a choice rule. A choice rule contains the comparison field and the next field. The comparison field consists of two fields that specify an input variable to be compared, the type of comparison, and the value to compare the variable to. The next field contains a value that must match a state name in the state machine. In the example on the slide, the first choice rule checks whether the numerical value is equal to 1. The second choice rule checks whether the numerical value is equal to 2. The parallel state creates parallel branches in your state machine. A parallel state causes step functions to run each branch, starting with the state that is named in the branch's start at field, as concurrently as possible. The workflow will wait until all branches reach a terminal state before it processes the parallel state's next field. A wait state delays the state machine from continuing for a specified time. You can choose either a relative time, which is specified in seconds from when the state begins, or an absolute time, which is specified as a timestamp. You can use a wait state as a form of timer for your workflow. In the example on the slide, the wait state introduces a 10-second delay into the state machine. You can use the map state to run a set of steps for each element of an input array. While the parallel state processes multiple branches of steps by using the same input, a map state will process the same steps from multiple entries of an array in the state input. A succeed state stops running a state successfully. The succeed state is a useful target for choice state branches that do nothing except stop running the state. Because succeed states are terminal states, they don't have a next field, and they don't need an end field. A fail state stops running the state machine and marks it as a failure. The fail state requires the type field, which specifies the state's type. In addition, the fail state allows the optional cause and error fields. The cause field provides a custom failure string that can be useful for operational or diagnostic purposes. The error field provides an error name that can be used for error handling, operational or diagnostic purposes. Because fail states always exit the state machine, they don't have a next field, and they don't require an end field. The slide provides an example. Step Functions is integrated with Athena to facilitate building workflows that include Athena queries and data processing operations. This integration helps you create repeatable and scalable data processing pipelines as part of a larger business application. You can visualize the workflows on the Athena console. In the example on the slide, the raw data is in a tab-separated values or TSV format, and the data is ingested daily. As information is ingested, the AWS Glue crawler is used to provide updates to the raw data catalog. You use the Athena unload statement to convert that data into Parquet format. After conversion, you send the location of the Parquet file as an Amazon Simple Notification Service or SNS notification. You can use Amazon SNS to notify downstream applications to take further action. One common example is to initiate a Lambda function that uploads the Athena transformation result into Amazon Redshift. Here are a few key points to summarize this section. With step functions, you can use visual workflows to coordinate the components of distributed applications and microservices. You define a workflow, also referred to as a state machine, as a series of steps and transitions between each step. Step functions is integrated with Athena to facilitate building workflows that include Athena queries and data processing operations. This section summarizes what you've learned and brings the module to a close. This module discussed the benefits of automating your pipeline by using infrastructure as code and step functions. You examined the role of CI/CD in pipeline deployments. You learned about flow states and step functions and how to use them to control and direct your workflows. You also examined the elements of the Step Functions Workflow Studio. Here is the sample exam question for this module. A data engineer is using step functions to automate a pipeline to handle an analytics workload. They're using the Workflow Studio interface to drag and drop components into the workflow. However, the engineer isn't sure if the auto-generated code will perform the tasks and processing that are required. Which element of the step functions interface can they use to examine the code for accuracy? What are the key words in this question? The key words in this question are as follows. The question notes that the data engineer is using the Step Functions Workflow Studio to build the workflow, and they want to review the code that's being auto-generated for them. Now, let's look at the answer choices. A, use the States browser to examine the code. B, use the Form panel to view the code. C, review the definition area on the Inspector panel. Or D, run the Step Functions workflow and examine the output. Based on the keywords that were identified in the question, which answer is correct? We'll pause a few seconds before discussing the correct answer. If you need more time to consider the answer choices, pause the video. The correct answer is C. Choice A, use the States browser to examine the code, doesn't provide a method to view the code that is associated with the states and actions that are available to select. Choice B, use the drag and drop elements of the Form panel, would provide the ability to select the individual states and actions that are part of the workflow. However, the Form panel doesn't present any information regarding the code that's generated. Choice D, run the Step Functions workflow and examine the output, will only run the workflow and present the output. Of the options available, using the definition area on the Inspector panel is the only one that enables a user to examine and verify the code that is auto-generated through the Step Functions canvas. C is the correct answer. That concludes this module. The Content Resources page of your course includes links to additional resources that are related to this module. Thanks for watching.